So this is my fifth video about the demonstration practice video. It's going to be showing a chemical reaction. It's going to be the exothermic reaction. It's going to be directed to students, sixth grade students that are doing some lab chemistry reaction. Some of them like and some don't. So I was invited to this school to see if I can convince or make the look chemistry fun. So we'll see how it goes. So good morning, students. My name is Professor Carlos Hernandez, and I teach chemistry in the South St. Paul Middle School. I was invited here by your teacher, your chemistry teacher, to trying to show you that working in the lab with some chemicals and doing some chemical reactions can be fun also. I know some of you probably are scared about it, but no, everything is scared in there. Just think about like you're creating things with another things. When you put them together, you have something new, and that is what about chemistry is. So I want to show you, demonstrate you something I call exothermic reaction. Now, that's a fancy word, exothermic reaction. But so most of the science words are like two words together. In this case, exothermic. Exo means outside, thermic means heat. So what is this? Is the heat in the outside. What exothermic does is like take the heat to the environment, to the outside. You know, let's say for example, one example of exothermic reaction, it can be, for example, that we have those hand warmers. We have hand warmers that you can break them, that you can buy in any store. You can break them, shake them really hard, and that creates heat inside. You notice that it gets hot right away because there's some chemicals inside that when they break together, it creates heat, and then you use those in your gloves and your pants and everywhere else to keep yourself warm. Now, another example of exothermic reaction is maybe we have it's fall now, so we're trying to create. We're trying to keep ourselves warm. What we do is we go outside, we make a bonfire, we eat some marshmallows, we put the logs, create fire, and the fire around keep us warm. That's why we put our hands sometimes like really close to the fire because it's taking some fire outside, some heat outside. Now another thing that we can do is also another thing that we can do is for another example of about exothermic reaction is something probably you see on TV when the skyrockets are launched to the space. Now that creates that need like so much energy, so much force to get out of to break gravity and go through space. And now they need some heat, so that they have these two huge tanks full of fuel, and that creates some foam, or not some foam, but some gases in there with aluminum oxide, and that is full of heat. Now that's another example of exothermic reaction. Another one can be when back in the old trains, the locomotives, they used to have these engines that you have to this huge oven full of fire when the conductor was shoveling coils in there. What the shovels, what they do some combustion, that we can see the gas was coming out of there to some pipes and making the wheels of the train go faster and faster. And that's exothermic reaction. Also, they use the heat to make the train going faster and faster to keep going. And the contrary of exothermic reaction is endothermic reaction. Endo means inside, thermic heat. So that means that they use the heat that's outside for the inside. One of those examples, again, you see the leaves are changing colors right now in many parts of the state. So you can see that that's another example of endothermic reaction, which is photosynthesis. It's changing the colors of the leaves. Another one can be also we eat food, and it give us energy to keep going, and that's another example of endothermic reaction, the creation of ATP, or glycolysis for that matter. And so that's one example of the endothermic. But we're here about to do some fun stuff about exothermic reaction. So we're gonna have here some hydrogen peroxide, 3% only in this case, and we're gonna mix that with some other ingredients. We have this empty bottle that we're going to pour some hydrogen peroxide in there, just like a cup, inside, and we're going to put some food coloring that they use for the color your cupcakes, your cookies, and you pour in there a big amount, you can say, and we're going to put some dish soap that's going to help us to create the foam, the foamy part. We pour it in here, and also we switch it, we mix it, it's all good, and we rest it, we put it there. Now, hydrogen peroxide has an extra molecule of oxygen, so it's H2O2, and we need to catalyze something that takes that extra molecule of oxygen out of it. And for that, we're going to use this yeast. This yeast actually helps to make bread. You can find it in your kitchen. You don't need to buy any of these ingredients. I think probably your mom already has everything in this kitchen. And the hydrogen peroxide probably is in the bathroom. Just be careful when you use that stuff. So, and then the catalyst is going to help to take that extra oxygen out of the peroxide out of there. So we only have oxygen in there. And the molecule of the extra molecule of oxygen is going to get into the foam of what we're going to create, and that's going to make the foam come out like a volcano. You will see pretty soon. And also the catalyzer, the yeast, we're going to mix it with some hot water that we have in this cup, and we mix it, make sure that you don't have any crumbles or anything like that. Make sure that all nice and very diluted, and then we're going to pour in this bottle. And we sit it here, and that's when the fun begins. You see the foam coming out. It's spreading all over the place, making a big mess. But here, when we touch the bottle is hot. That's an exothermic reaction. The combination of those ingredients create heat. If you think about it, this soap, yeast, hot water, the hydrogen peroxide, everything has created this fun foam and also some heat. And that is what an exothermic reaction is. You can have fun in the chemistry lab. You can go over there, talk to your teacher. Maybe he can have some extra samples or extra fun chemistry combinations that you can do and make it nice and easy for you. Don't struggle. Don't think that this is too hard, too difficult. It can be messy, which is fun. Making a mess sometimes is fun, and then you can enjoy it. So I hope you like my experiment, and I hope you can go do this at home also with the help of an adult, and then you can have some fun. So chemistry is not scary; it's actually fun. So I hope you enjoy.